Hey, what's up? This is Steven,
Maddie, Laura,
and Matt.
One topic that piqued our interest from the Geospatial Revolution video series was found in Episode 4, Chapter 1, titled Monitoring a Changing Climate. As environmental enthusiasts, we understand how important studying climate change is to society and our environment. Geospatial science techniques and data are used to monitor how the climate changes over time. Mapping ultimately tells us how the Earth works, where things are, and how they're related to paint us a picture of what is really going on. In the video, Greenland and its neighboring area was the focus, and whether its ice was increasing or decreasing was the topic of concern. Satellites make observations over a temporal period to see how fast the ice goes over time. The data is turned into a map so you can see where it is thickening, thinning, or dropping icebergs the most. Geospatial technologies allow us to see other factors affecting climate change, such as deforestation areas, leading to a release of hundreds of years of CO2 into the atmosphere, and then the mapping where the highest concentrations can be found in our atmosphere. As climate changes, we need to know the extent of what those things are and the way they change through time, and geospatial technology will allow us to see that.
Our top-level geography category is physical geography. Physical geography examines the distribution of Earth's surface features such as forests, mountains, and ice. Physical geography also analyzes the processes that create and shape landforms. There are many subdivisions of physical geography, but the one we'll concentrate on today is climatology. Climatology is the study of climate and the features that affect past, present, and future. A climatologist attempts to discover and explain the impacts of climate on Earth.
What type of people work on these projects? Job opportunities related to physical geography. Crisis response coordinator. Earthquakes, fires, floods, storms, and terrorist attacks are just a few of the emergency situations faced by communities. Understanding these climate extremes helps better plan communities for damage and emergency plans. Coastal Zone Manager. Background in geomorphology is useful in this career path. Understanding erosion to protect coastal environments and towns is important. Habitat Researcher. Biogeography uses a combination of biology and geography to better understand flora and fauna and aid endangered species in renewing populations. Organizations. National Geospatial Intelligence Agency. Geospatial intelligence experts. Anyone who sails a U.S. ship, flies a U.S. aircraft, makes a national policy decision, fights wars, locates targets, responds to natural disasters, or even navigates with a cell phone relies on NGA. Environmental Protection Agency. EPA's National Geospatial Program coordinates the agency's geospatial data, applications, policies, and programs. U.S. Department of Agriculture. The ability of GIS to communicate complex concepts helps people to better understand region-wide and site-specific agricultural issues. Education. Educators trained in geography can teach at the elementary, secondary, or college level. Geography is a spatial science allowing one to incorporate it into just about any interest. Each state now has a geographic alliance with the goal of improving geography education. Education in religion. Religion has many geographic dimensions, including how religions spread or remain confined to a particular area. Education in music. Music geographers also seek to understand how music is tied to place. Skills. Involves the use of maps, aerial photographs, satellite images, the global positioning system, and sophisticated computer software. Skills may include use of cartography, create maps with a variety of tools, geographic information systems, and intelligent mapping systems that allow overlay and analysis of different kinds of geographic features such as roads, rivers, soil types, and political boundaries. GPS, global positioning systems, determine locations using radio signals transmitted by satellites, and then remote sensing, collection and analysis of information about the Earth using satellites or aircraft-mounted sensors or cameras.